classes, there will be continuing our study of functions and relations, and we'll be continuing this study with the sums and products of functions. So these are reasonably simple. So basically what we'll be doing is, as this suggests, we'll be taking two functions and we'll be adding them, and then we'll be graphing what the new function is. And with products, we'll be taking two functions and just multiplying the functions and then graphing whatever the product is. So these ones are reasonably simple because we can just add and multiply the functions and then just graph whatever remains, and we don't really have to worry about what the functions were before we added or subtracted. So broadly speaking, there's two ways to do it, but in this case, because we've got the equations, the algebraic way is usually the easiest way, and I'll go over what that involves now. So basically, if we want to get our new function y, we're going to have f of x plus g of x. And in order to do that, we have to add our two functions. In this case, f of x is x cubed plus 1, and g of x is going to be x squared minus 2x plus 3. And so when we add these, we're going to get x cubed plus x squared minus 2x plus, oh, sorry, that should be a minus 3. And that's going to leave minus 2. So now, in order to graph this, well, first of all, this is our new function. We've successfully added the two functions. But this isn't the hard part. The hard part generally comes in when we're trying to graph them. So in this case, when we're trying to graph them, we don't need too many things to graph them. We just need the x and the y-intercepts. So let's start with the y-intercept. So how do we get the y-intercept? Well, we let x equal to 0. And if we have x equal to 0, then x cubed, x squared, and minus 2x, they're all going to disappear. So our y-intercept is just going to be y is equal to minus 2. And we also need our x-intercept. And in order to get our x-intercept, we have to let our y equal to 0. So in this case, if we let y equal to 0, we get this. X cubed plus x squared minus 2x plus, minus 2, that bracket. And so here, what we could do is we can pull out a x squared from the first few terms and then a minus 2 from the others and get this. X squared outside of, and we're going to be left with x plus 1 bracket minus 2. And here, if we pull minus 2 out of both of these, we're going to be left with x plus 1. That's nice. And now from here, we can pull out our x plus 1. So we're going to be left with x plus 1 bracket x squared minus 2. So this implies that our x is equal to minus 1, or that it's plus or minus the square root of 2. And that's because if we let this equal to 0, we move the 2 over and then we square root it. And whenever we square root it, we have to remember that it could be either plus or minus. So now let's graph this. So we know it's a cubic and it's got a positive coefficient in front of x cubed, which means it's going to start down here and end up here. And we know that it's going to cross the x-axis at -1. So let's say -1. Negative, that should actually be negative root 2 because negative root 2 should be bigger than 1. And then -1. And it should also cross at root 2. And it'll cross the y-axis at -2. So from here, it's pretty clear what the shape of the graph should be. So we just come up through here, cross through that point, cross through that point, go down through there, cross through there, and go up. And there we have it. We've successfully graphed the sum of this function. So an alternate way to do it would be to graph this cubic, which goes something like this, and then to graph the parabola, which should go something like this. And then you can add up each individual point and get an overall shape for the graph, and then you can draw it out. So generally speaking, if you're given the equations though, you just add them together algebraically and then you graph the new function. But for these ones, you would take, okay, so let's say I have x equals to 1. Well, what's this parabola at x equals to 1, and what's this cubic at x equals to 1, and then you add those, and then you graph that point. And you just do it on a point-by-point basis, and then you essentially join the dots. But that method is a little bit harder, and you generally don't use that as often as just adding them and then graphing the resultant function. So here, now we have the products of functions, and again, what we're going to be doing is we're going to be taking them and just multiplying them in order to get a new function, and then we'll be graphing that new function. So let's go ahead and do that. So y is equal to, and in this case, it's going to be f of x times g of x, and now f of x is x minus 2. And then our g of x is going to be x squared plus 2x plus 4. And so if we can expand this one out now, what we're going to get is x cubed plus 2x squared plus 4x minus 2x squared minus 4x minus 8. That's relatively simple. That's going to be x cubed minus 8. Yeah. So from here, it's actually going to be really easy to find our points for this, because this is, again, another cubic. And so let's draw our axes. And so if we want our y-intercept, that's relatively simple, because we just let our x equal to 0. So we're just going to be left with y is equal to minus 8. And then if we want our x-intercept, we have to let our y equal to 0. And then that's going to be 0 is equal to x cubed minus 8. And so x cubed is equal to 8. And so x is equal to 2. So that means that it crosses at negative 8 and it crosses at 2. And we know that this is a cubic, and it's going to look something like this. All right. So now we've essentially graphed our function. And this is the new function that we wanted after we multiplied a line and a parabola. Now, alternatively, we could do the same thing we were doing earlier, and we could draw our line. Sorry, that line is a little bit off. We can draw our line, and we can draw a parabola. Rather, not any parabola, we can draw this parabola, and it'll look something like this. And then we can go through and multiply individual points until we can get a general curve. But again, this isn't so much hard as it is just time consuming, and in an exam you're generally looking for the fastest way to do it. And generally speaking, doing this is the fastest way to do it. And if you are ever asked to multiply individual points, they will generally give you individual points to multiply, and those points will give you key information about the graph. So there might be points where it crosses the x-axis, or something similar. So generally speaking, you would be using the algebraic method, but if you're ever asked to do a point-by-point basis, they will generally give you the points or give you a range of points that you should be going over. Say graph this function between -1 and 1, and then at that point you might do -1, 0, and 1, and then you'll see how that graph turns out. All right, I hope this lesson was helpful, and I will see you guys in the next lesson.